If a rover drilling into the Martian crust tomorrow found a living, wriggling microbe, it would be celebrated as the greatest scientific discovery in history. But mathematically, it would be a death sentence. Finding even the simplest life on another planet suggests that the hurdle between us and extinction isn't behind us, it's ahead. To understand why, we have to look at the numbers. The observable universe holds billions of galaxies, each packed with billions of stars and habitable planets. With numbers that vast, life should be everywhere, and yet no Dyson spheres, no radio beacons, no sprawling galactic empires. In 1950, physicist Enrico Fermi famously summed up this contradiction with a simple question: where are they? Economist Robin Hanson proposed a solution called the Great Filter. The idea is that somewhere on the evolutionary staircase between dead chemistry and a star-spanning empire, there is a massive, almost impassable wall. A challenge so difficult that virtually no species ever survives it. This creates an inverse correlation. If life is incredibly rare, then the hardest steps are behind us. But if life is common, if we find microbes next door on Mars, it means those early steps are easy. And it means the Great Filter is still waiting for us. For decades, scientists used equations relying on point estimates, educated guesses about the likelihood of planets forming life, to predict the number of alien civilizations. But these estimates often assumed a false certainty about how easy it is for chemistry to suddenly become biology. This Oxford study maps uncertainty in the Drake equation. Adjusting for extreme scientific unknowns, the data shifts. The peak probability clusters around this red line, meaning we are likely alone in the Milky Way. This flat tail represents pessimistic scenarios where complex life essentially never happens twice. This is the most optimistic scenario for humanity. If the Great Filter is a freak chemical accident that we somehow already survived, then the empty universe is a mathematical blessing. It means the hardest part of cosmic evolution is in our past. But if we survey the cosmos and find ancient ruins or dead technosignatures on planets like Mars, the math flips. Finding dead civilizations proves that jumping from biology to intelligence is common. Growing civilizations consume vast amounts of energy, but the laws of thermodynamics are unforgiving. Energy use creates waste heat. It's a fundamental feedback loop where a civilization's growth inevitably bakes its home planet, driving carrying capacity to zero. Even if they survive their own climate, they face the threshold of autonomous AI, cosmo industry. Building self-replicating, automated manufacturing in space gives immense power, but introduces irreversible risks of machinery terminating their creators before they establish a multiplanetary foothold. If the cosmos is littered with species that reached radio technology and then vanished, we are walking on a well-worn path toward a cliff. We are approaching a developmental bottleneck that kills everyone who tries to squeeze through. There is another category of filter, one that doesn't rely on self-destruction, but on active predation. The Berserker hypothesis suggests an ancient, advanced civilization unleashed self-replicating von Neumann probes, machines programmed to quietly multiply, scan the stars, and systematically exterminate any new intelligent life before it becomes a threat. Expanding on this is the dark forest theory. Imagine the universe is crowded with civilizations, but because interstellar distances make communication slow and intentions impossible to verify, the only rational response to detecting a neighbor is a preemptive strike. In this scenario, the universe is dead quiet because it is filled with paranoid survivors. The silence is a survival strategy. Every civilization learns that transmitting a signal is an invitation to be destroyed. The Great Silence transforms from a cold mystery into a mirror, reflecting our own survival back at us as the only variable that matters. It strips away the illusion that survival is guaranteed. Astronomer Carl Sagan suggested that navigating these filters requires a psychological leap. To truly become an interstellar species, a civilization has to outgrow its violent predatory origins. An intelligence that remains aggressive and short-sighted will inevitably wipe itself out long before it solves the physics of deep space travel. Physicist Brian Cox argues that our earthly challenges, nuclear weapons, climate stability, and cooperation, carry a cosmic weight. These are the literal markers of the filter itself. Failing to overcome them would prove that we were never destined to leave our cradle. If we are alone, we carry a unique responsibility. We hold the only candle of consciousness in the Milky Way. Failing here would permanently extinguish the universe's only chance to observe itself.